So I'm sure some of you jumped to this method. And if you don't have a calculator handy, this method might be a little bit of a pain. It might not be difficult for some of you, but some of you might find it very difficult. You don't want to multiply it out at all. You'll have tons of zeros there. But another hint would be to think about 10,000 as 10 to the fourth. 10 squared is 100. 10 cubed is 1,000. So if I do 10 times that, 1,000 times 10 is going to get me 10,000. So really I could be doing 10 to the fourth times 10 to the fourth times 10 to the fourth. And let's use that rule right up here. Multiply powers is adding exponents. So 4 plus 4 plus 4 gets us 12. So it would be 10 to the 12th power. Or it would be that on a calculator. And your calculator might have given you something that looks like this. If your calculator gave you this, that's the same thing. That just means 1 times 10 to the 12th power. But we'll talk more about that later. That's really scientific notation. But really the goal is to get this as your answer. 10 to the fourth times 10 to the fourth times 10 to the fourth. All right, let's start with our new rules then. Okay, so we know that an exponent tells us how many times to multiply something. So that 2 really means that we're going to have 10 cubed times 10 cubed. All right? And this 5th power means we're going to have 10 squared times 10 squared times 10 squared times 10 squared times 10 squared. We're going to have 5 of those 10 squareds. So we're going to see what these all look like in expanded forms and see if we can get a pattern for writing as a single power of 10 over here. So here we had 10 cubed times 10 cubed. And then they wrote that in expanded form, expanding it out. All right, so that 10 cubed is 1, 2, 3 tens, and 4, 5, 6 tens total being multiplied. So that's where we got 10 to the 6th from. So then here, when I do my 5 10 squareds, how many tens is that total we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens. So I'd be at 10 to the 10th power. All right. And let's see what's going on here. How many groups do I have? I have 1, 2, 3, 4 groups. And what's each group? Each group is 10 times 10 times 10. That's 10 cubed. So how many 10 cubed do I have? I have 1, 2, 3, 4 10 cubed. So I really have 10 cubed to the 4th power, because I have 4 groups of 3. And this wording we're using kind of sounds like multiplication. I have 4, if I buy 4 packs of, I don't know, gum, and each pack of gum has like 3 sticks in it. You get 4 packs with 3 sticks each, you get 12 total sticks of gum. And that's the same thing here. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tens, because I have 4 groups of 3. So I'd really end up with 10 to the 12th power. 4 groups of 3. All right. So let's think about the next 2. What would the next 2 look like? Well, I have 2 groups of 10 to the 4th. So I have 10 to the 4th times 10 to the 4th, which is really just 10 times 10 times 10 times 10. That's 1 10 to the 4th. And then I have 10 times 10 times 10 times 10. And really all I'm doing is counting how many times am I multiplying by 10. 7, 8. So we got 10 to the 8th power, because I have 8 tens. And notice what's happening to my first 2 exponents here. All right, what do I do to 3 and 2 to get 6? What do I do to 2 and 5 to get 10? What do I do to 3 and 4 to get 12? And what do I do to 4 and 2 to get 8? If your answer was multiply, you're absolutely correct. This is how all math is discovered. People just simplify things and notice patterns. 2 groups of 10 cubed gets me 10 to the 6th. 5 groups of 10 squared gets me 10 to the 10th. I get 10 total 10s. So 3 times 2 equals 6. 2 times 5 equals 10. 3 times 4 equals 12. 4 times 2 equals 8. What's this exponent going to be? If I have 11 groups of 10 to the 8th, what's my exponent going to be? I'm not writing the expanded form out. And why am I not writing expanded form out? I don't want to write 11 groups of 10 to the 8th. 11 groups of 8 is how many? 10 to the 88th power. I'm going to write 88 better than that because it looks like a blob. It's 10 to the 88th power because I have 11 groups of 8. All right. We chose to skip an entry in the table, that bottom one. We chose that one because too many numbers. So using the patterns you found, how could I rewrite this as an equivalent expression? So this is basically our general rule, m and n. I don't know what m and n are, but I know that I have to multiply the exponents. How do I multiply m and n together? Well, just m times n. So that shadow is killer. I'm going to move this light. Very sorry. So multiply my exponents, and that gets me 10 to the m times n power. All right. So if you took the amount of oil consumed in 2 months in 2013 worldwide, you could make a cube of oil that measures 10 to the 10 cubed meters on each side. So really it's 10 cubed by 10 cubed by 10 cubed. This is my drawing of a cube. It's actually not terrible. It covers the direction, so it's not very good, but that's a pretty good drawing of a cube. We'll get there. It takes me back to the day we practiced drawing cylinders, cones, and spheres in class. Guys, I'm so good with that. There's my cube. Maybe I'll make it face the right side of the paper. There we go. There's our cube. So how many cubic meters of oil is this? How could I write this? It's kind of like our first cube problem. Well, I got 2 options. Option 1 could be, well, volume is length times width times height. So it could be 10 cubed times 10 cubed times 10 cubed. Or I could think that volume is the side length cubed. It's the same number, so that times that times that. It's all the same thing. So it could be 10 cubed cubed. So what do you get for each of these answers? Give it a pause. You should get the same number for both places. Give it a try. So if you do this one, we're multiplying powers. So what do you do to our exponents? Add exponents. So 3 plus 3 is 6, plus 3 is 9. The power of a power means I multiply my exponent because I have 3 groups of 3. And 3 times 3 is 9. So I get 10 to the 9th power meters cubed of oil. All right, so let's look at our second rule on the back. Good start. Don't be scared of those fractions. They're really not bad. So our next rule has to do with dividing of powers of 10. So we're going to follow the same format. We're going to do expanded form, and then we're going to just see what we notice. All right, the first one's done for us. So we have 10 to the 4th divided by 10 squared. So that really means we have to do this, and then divide the results. So in our first fraction, pink's dying already, what the heck? In our first fraction, we have 1, 2, 3, 4 10s on top, and 2 10s down below. And if you remember simplifying fractions, which you might not, because not a lot of grades prioritize, that's okay. I can see, oh, I have a 10 in my numerator factor and a 10 in my denominator factor. So I can simplify this by a factor of 10. It's like saying, this is an aside, It's like saying that 2/4 is the same as 1/2, because really what this is I have 1 times 2 over 2 times 2, because 1 times 2 is 2, and 2 times 2 is 4. So I can divide both of these numbers by 2, divide the pieces and divide the whole by 2, and get 1/2. It's like saying that a pizza cut into 4 pieces, if I have 2 of those, that's 2 out of 4. But also, that's the same exact portion as if I have a whole pizza cut in half and I take this whole half over here like a monster. So it's really the same exact thing. And I could do it for powers of 10, but I can't draw the same thing. So basically, it's the same type of rule you've probably seen or been familiar with in the past. So I can divide out that power of 10, and I can divide out this 10. And that's kind of what they did here. They took out 2 of those, 10 times 10 over 10 times 10. And this is really just 100 over 100, which is just 1. So it's 1 times 10 times 10, which is just 100, or 10 squared. All right, so this is kind of messy. I understand that. But basically what's happening is we went from a 10 to the 4th divided by 10 squared and got 10 squared. All right, and we'll do the same thing for each of these. So here, let's look at this. This is a division problem. Again, it's a fraction. So it's what divided by what? I see I have 1, 2, 3, 4, 5 tens. So it's 10 to the 5th divided by 1, 2, 10 squared. And when I do all that, I can again take out 2 of these 10s. And that leaves me with 1, 2, 3 10s. So I have 1, 2, 3 10s left, which is really just 10 cubed. So let's look at our exponents. What happens to our exponents here? 4 and 2 makes 2. 5 and 2 makes 3. 6 and 3, let's see. 10 times 10 times 10 times 10 times 10 times 10 over 10 times 10 times 10. So there's our 10 cubed. There's our 10 to the 6th. How do I simplify this? Well, I've got an extra 10 being multiplied on the top and bottom, an extra 10 being multiplied on the top and bottom, and an extra 10. So I'm really just simplifying that fraction more and more and more. It's like turning 10 out of 20 into 1/2 by dividing by 10. All right, if 10 out of 20 kids did their homework, I would say a half of kids did their homework. I wouldn't say 10 out of 20, I'd say half. So it's just simplifying it. And again, how many 10s am I left with? I'm left with 10, 1, 2, 3 10s, which gets me 10 cubed. Sorry. So in all these cases, what am I doing to my exponents? And some of these examples I don't like because there's kind of 2 different answers. No, there's not. This one up here, 4 and 2 makes 2. What are my possibilities? 4 blank 2 gets me 2. Well, I could say 4, it doesn't even work. I could say 4 divided by 2 gets me 2, or 4 minus 2 gets me 2. Let's look at the rest of them. 5 blank 2. What do I do to 5 and 2 to get 3? Can I do 5 divided by 3 or 5 minus 3? Well, that, because 5 divided by 3 is a fraction. Same here. 6 minus 3 gets me 3. So that works. 6 divided by 3 would get me 2. Does not work. So it's not division, it's got to be minus. So I'm subtracting exponents. So 43 minus 17, let's see, 43 minus 7 is 36. 36 minus 10 is 26. So I would have 10 to the 26th power there. If I have 43 tens and I cancel out or simplify out 17 of them, I'd be left with 26. So my exponent here, if I'm rewriting 10 to the n over 10 to the m, I would write this as 10 to the n minus m power. All right. So this is like a nice Earth Day problem because Earth Day was like, 5 days ago, finally catching up. To be fair, when I'm recording this, Earth Day was, okay, 2 days ago. It's Friday, so whatever. 2 days ago. By 2050, there will be 10 to the 10th people living on Earth. So 10 to the 10th is really just, let's see. Fun fact, that really tells you how many zeros that 10 has. So it's got 10 zeros. So that is 10 billion people. Cool. Nice to know. By 2050, there'll be 10 billion people. I think there will be more than that sooner, just for the record, but whatever. At that time, it's predicted that there will be approximately 10 to the 12th trees. I don't know where that number came from, but it sounds like they made it up. So 10 to the 12th is really just 10, and I'll do the same thing. 12 zeros. You can test it. It will work. That is 1 trillion trees. Cool. So how many trees will there be for each person? And learning about these exponents is useful because sometimes calculators, like if you do little school calculators or if you don't turn your phone calculator to the side, they can't really handle big numbers like this. It's good to know the little shortcuts. So 1 trillion trees. How many trees will there be for each person? So we gotta do trees divided by people. So 10 to the 12th divided by 10 to the 10th. And if I don't know about my exponent rules, I could type in 1 trillion and probably count my zeros wrong, divided by 10 billion, and again, probably count my zeros wrong because Mr. Obodo's bad at counting. Or I could use my new rule and do 10 to the 12 minus 10. And 12 minus 10 equals 2. So it's 10 squared, which is 100 trees per person. Okay? So we're going to summarize our 3 rules that we've learned, and we're going to use them for our exit slip, okay? Awesome. Okay, so if there's any part of the video you're going to focus on or rewatch, this is the part to rewatch, all right? This is the part that you really want to make sure that you are viewing. Even if the first part didn't make sense, this is like where the real, like, the synthesizing of everything comes in. So we now have 3 different rules we're looking at. And just to review, we call just the number or the value standard form, 10 million. Cool. That's the actual number we're dealing with, all right? So population of New York, population of cities, okay? Big number. In exponential form, that's where we write the number as a power. So this is in particular a power of 10. And there's other powers you can talk about. Powers of 10 are easy to conceptualize because we live in a base 10 world. We talk about numbers in tens, hundreds, millions, thousands, billions. We talk about powers of 10. So that's like the most normal way to talk about numbers. So exponential form, power of 10. Then we have expanded form, which is a more concrete way of looking at these numbers and generalizing rules. So 10 times 10 times 10 times 10 times 10 times 10 times 10. So 10 multiplied by itself 7 times. All right, so we learned 3 rules in the past couple days. We learned the product of a power rule, power of a power, and quotient of a power. And just remember, the word product means multiply. It's a multiplication problem. A power of a power is an exponent. So it's when a power of 10 or power of anything gets an exponent. And a quotient of a power is just division or fraction. All right. So we gotta look at how to tell when to use each rule. So if you have a product of a power, let's just pick a couple. I'll use the same numbers for each one. Let's say we'll do 10 to the 5th power times 10 to the 3rd power. We'll do that. So now in our product of a power rule, remember, what did we have to do to our exponents? Remember? we had to add our exponents. All right, because we have a group of 5 and a group of 3. Totals to get me a group of 8 tens. All right, let's try the next one. The power of a power rule. Let's say I had 10 to the 5th power, and I'm raising that to the 3rd power. I'm cubing that. Let's say the side length is 10 to the 5th, 100,000 miles wide, and it's a cube. Well, things that are that wide aren't cubes. They're usually spheres, because gravity's taken control and turned it into a sphere. That's very scientific. Okay, so I have 3 groups of 10 to the 5th. So that means in expanded form, I have 10 to the 5th times 10 to the 5th times 10 to the 5th, which really means I have, I made these numbers too big, 10 times 10 times 10 times 10 times 10. That's one group. A second group. Oh, geez, an ugly 0. And a third group. Sorry, move a little bit over. All right. So then how many 10s total do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tens. Or I could multiply my exponents. I should have left myself more space. That's my catchphrase. I knew I should have left more space. I said it in school, and I'll say it every day over summer. I should have left more space. So that would be 10 to the 15th power. Stop laughing at me. Okay. 10 to the 15th. Okay, so there's that. Now I'm going to do my quotient rule. So I'm going to divide. So now I'm going to do 10 to the 5th divided by 10 cubed, or 10 to the 5th over 10 cubed. And I'll put it in expanded form. So we got 10 times 10 times 10 times 10 times 10 divided by 10 times 10 times 10. And I'm going to simplify this by saying, well, all right, I've got 1,000 extra being multiplied on each top and bottom. So get rid of 3 factors of 10. So then I'm just left with 10 times 10 over 1, which is just 10 squared. So really, I can subtract exponents. I hope the color coding is going to help you guys, because if you see a problem that looks like the red one, you're going to follow the rule for the red. If you see a problem that looks like purple, follow the rule for the purple. When you see a rule that looks like pink, it'll look like this probably. The pink, you're going to follow the rules for the pink, okay? This is your day to really practice this. If you don't do well on this, this is one that you should go back and revise. Ask specific questions. Mr. Roboto, how do I know which rule to use? Mr. Roboto, this rule doesn't make any sense. Please ask me, whether it's an email or however you want to ask me. Private comments, Google Classroom. Public comments are also good, because you guys have been asking really good questions as you've been asking them. So please don't be afraid to leave a public comment that is a question about material, okay? Because I'm sure other kids have the same question. All right, good luck. And remember, keep this open, or keep the note page that I'm going to attach open for your exit slip, all right?